Go.
Hello everyone, this is Purva Choudhary and Roopthi Kata, and today we will be presenting our research, which was titled Identification of Relevant Features on a DDoS Attack on SDN. Um, please, next slide, please. So, in this research, we will be looking into the various features uh, and the change in their values and how a DDoS attack on an SDN can be identified and further worked on. So now to give you a bit of introduction about software-defined networking. Software-defined networking is a technology that separates the data plane and a control plane of a network device and lets the devices in the network plane be controlled by the SDN controller in the control plane. So basically, if you have multiple devices in the data plane and you have one device in the control plane, and they communicate with the devices in the data plane, communicate with the SDN controller in the control plane using an open flow protocol. And that is like with that communication, the controller dictates the devices in the data plane which how the packet should be routed and everything. So yes, the SDN uses open flow protocol to communicate between the data plane and the control plane. Next slide, please. So as we can see here, we have multiple devices in the data plane, and they all are connected to the SDN controller in the control plane. Um, and Yeah, so there's communication using open flow protocol, and the interface for it is the southbound interface. Next slide, please. So now we will first look into what is a DDoS attack. A DDoS attack is a distributed denial of service attack. DDoS attacks work when overwhelming the target website or application server with large amounts of data packets or traffic. This makes the server of the target website or application incapable of responding to the legitimate user requests, and that way, um, it is not able to send back the response to the legitimate users because of overwhelming packets from uh, illegitimate uh, attack users. Next slide, please. So now that we know what is the basics of an SDN and a DDoS attack, we also understand that DDoS attacks are especially very harmful for SDN networks. And why is that so? So there are two ways in which DDoS attacks can happen on SDN very easily. First way is the attacker can send large amounts of traffic to the devices in the data plane. And if the packets arriving to the device do not match with the entries in the device flow table, which is actually written by the SDN controller, the packets are sent directly to the SDN controller. Now, if a lot of such packets are sent to the SDN controller, because they are attack packets, so there will be a lot of them, then the SDN controller becomes incapable of handling the large traffic and thus becomes inoperative. A second way in which DDoS attacks can happen on SDN controller is if the attacker sends data to the data plane device from unknown sources. In this case, the SDN controller writes routes for that arriving packets to the flow tables of the data plane devices. But after a while, if uh, packets are coming from various different data sources, then it become like a lot of rules are being written to the flow tables, and after a while the flow table overflows and no new rules can be written, and the incoming packets are also dropped because the flow tables are overflowing, um, and the attack is successful that way. Next slide, please. So now that we know that, there are these, that is how DDoS attack is very harmful for SDN. Then we in this project are trying to detect such DDoS attacks using by identifying the features. Now, to do this, we have used various development and simulation tools, which we have used SDN with OpenFlow protocol. Then we have used RYU SDN controller. Rupti, next, no, earlier slide, please. We have used RYU controller. We have also used simulation uh, softwares. Earlier slide, please. Like Mininet, iPerf, and Hyping. So yes, these are the development and simulation tools. Please, next slide. Thank you. Now, to look at the parameters being calculated. So now that as I told you, we need to evaluate and distinguish between normal traffic and attack traffic. So the features that we were talking about, the three features which we came about were these. First is the IP source frequency. IP sources frequency is the number of incoming IP sources detected for the given time period, and which basically means that if packets are coming from different IP sources, then for a normal traffic, the number of IP sources for a given time period will be small. But if it is an attack traffic, then the number of IP sources will be very large, because DDoS attacks happen from various different IP sources. And second criteria is incoming packet frequency, which is the number of incoming packets received within a particular time period. Now, for normal traffic, you will have a moderate amount of traffic coming to the server, website, or application. But if it is a DDoS attack, you will have a large number of packets coming. And that is why here we measure the number of incoming packets received for a given time period. That is the incoming packet frequency. Um, Third slide, please. Next slide, please. Now, the third parameter which is there is the number of IP sources divided by the number of packets received. Now, this is important because the number of IP sources, it gives us a general idea about how many IP sources divided by number of packets received. And if this value is small, then this is a normal traffic. But if this value is high, then we know that this is attack, and we need to then further take steps for it. Next slide, please. Now, coming to support vector machine. Now, initially, we had started this project out with only the aim of figuring out these parameters, and how these parameter values change for a normal traffic and for an attack traffic. But as we went ahead, we are very proud that we not only were able to detect these parameters, but also make changes, and like be able to work on um, detecting a normal traffic and an attack traffic, and also blocking attack traffic for a limited period of time, using machine learning algorithms and all. So the machine learning algorithm we use here is the support vector machine SVM, which detects, which is able to differentiate between normal traffic and attack traffic. SVM algorithms work by cla- it takes the data, and then it classifies the data into two parts. They are basically classification algorithms, and when by learning from this, if you get a new data, then it is able to classify that data into one of the two groups. And so here the SVM trains itself using the data set for normal traffic and attack traffic, and learns to differentiate between the normal traffic parameter and values and the DDoS attack traffic parameter values. Next slide, please. So yes, The methodology we use here is data collection for the normal traffic, the attack traffic, and third part is using SVM on this data set to train and then to predict the traffic as normal or DDoS attack traffic. Next slide, please. With that, let me transfer the control to my partner Roopthi, and she will go ahead.
Hello everyone, my name is Roopthi Kata. I'll be showing you the demonstration of our project. So this is the video link of our demonstration that we have recorded and stored. You can go there and watch. So we have set up all our project in the Ubuntu virtual machine. So let me go there and log in. So here is my project. So here is my project and this is the source code. Let me open and show you the code. Okay, so here is my controller, which is RYU controller. This script is written in Python. And this is the code for topology, which currently has 1 switch and 10 hosts in it. And normal.sh is the script for generating normal traffic, and attack.sh is script for generating the attack traffic. You see, we are doing this through hping 3. So here we are going to demonstrate you like different kind of test scenarios. So first, we want to generate and collect the data for normal traffic. So in order to collect the data for normal traffic, we need to give app type equals to 0 and test type also equals to 0. If you see here, we mentioned it clearly in the script. 0 is for data collection. And yet test type is 0 for normal traffic. So first we have decided to collect the data for normal traffic. That's why we are giving app type is 0 and test type is 0. And we are collecting the data at the interval of every 3 seconds. I will show you how exactly this is happening while running the controller. So this is done, and in the topology, we need to give test type as normal since we want to collect the normal traffic first. So I have changed it to normal and save it. And let me save this file as well. Okay, so let's go to the controller and run it. So I'm going to my terminal. I'm in my source code folder. So let me run the controller. Before that, I make sure to clear the cache. And for topology as well, let me clear the cache first. So let me run the controller. So it is waiting to collect the traffic. So let's generate the normal traffic from the topology. See, if you can see here, it's saying generating normal traffic. So now the controller should start receiving the normal traffic, and it is receiving. As you see, these are the values in the brackets for normal traffic. If you see, these numbers are lower, which is a normal traffic, These values represents incoming packet frequency, IP sources, and source IPs per packet. And as I said, it is collecting the traffic per every 3 seconds. If you see the timestamp, you can see it's collecting for every 3 seconds. So we are good. So we are generating normal traffic and collecting. It will generate the CSV files with this data. I will show you once I am done with running the controller. So now let's close this and go to next scenario. So now let's generate the attack traffic and try to collect the data. So in order to generate the attack traffic, we need to change in the topology as a test type as attack and save it. And in controller, the test type should be 1 as we are collecting the data for attack traffic. So I have saved both the files. So let's go there and run the controller for attack traffic. So as usual, let me clean up my cache. And let me start running the controller. Okay, looks like I have already run the topology. So now it says it's generating attack traffic. So now the controller should start receiving attack traffic. If you see these numbers, these are very higher than the normal numbers. If you see our previous numbers, these are like, this is how the normal traffic looks like, but these are very high. That means the attack is happening. The counts of source IP and the speed of flow entries are much higher than the flow ratio. And the flow ratio is almost lower than 0 or equals to 0, which is definitely different than normal traffic. So this is attack traffic, and uh, we collected it. So we are good here. Let's close this and go to next scenario. So far we have generated both normal traffic and attack traffic, and we collected the data in a CSV files. It will generate a CSV file. So let me show. If you see switch one data and flow count, these two are the CSV files generated when we run the controller. So next, the actual thing, we need to, our actual motto is to find the DDoS attack and mitigate it. So let's try to do that. So before running and detecting DDoS attack, it is always recommended that we should collect normal traffic data as well first. That way, it will be easy for us to see the normal traffic versus DDoS traffic and understand the results. So first, let me run the normal traffic. So in order to do that, let me go to my topology and change test type as normal and save it. And in controller, now we are not collecting the data. Now we are going to detect the DDoS attack. So let's give app type as 1. Here test type is doesn't matter for detection, hence why, because now we are not collecting the data, we are doing detection. So we are good here. So let's go and run the controller. Always let me clear the cache. And let me run the controller. It is waiting to see the traffic. So let's generate the traffic from topology. Seeing, as you see, it's generating normal traffic. Now the controller should start receiving the normal traffic. You can see here it's saying it's receiving normal traffic, and the numbers are very low. These values, so it is determined that we generated normal traffic and controller is receiving normal traffic. So we are good here. So let's close this and let's go to the actual uh, DDoS attack, which is our main motto. So now I'm gonna generate the DDoS traffic and let's see how we are mitigating it. In order to do that, let me go to my topology and change the attack type as, change the test type as attack. And in controller, it doesn't matter. It's already app type is one, which means we are detecting the DDoS attack. So now let's go to the controller and run. Let me clear the cache first to make sure our results are accurate. We need to clear the cache every time because we are changing the traffic type every time from normal to attack to normal. So let me run the controller. And let's generate the traffic. Now it says it's generating attack traffic. See, we are generating attack traffic from port 1. As soon as it detects the traffic from port 1, and then it is blocking the port 1. See it block. So we have set the hard time of 120 seconds to block the attack traffic, meaning it will block the attacking ports for 120 seconds and then it will release after 120 seconds. And after 120 seconds, if it's again receiving the attack traffic, and again it will block. You see, it's and right now, like we have coded in a way that we are generating attacking traffic only from the host one, which is H1, and the rest is rest all host traffic as normal traffic. So this is how it works. If you are generating like if we are generating traffic from more than 200 seconds, for example, in the file I have given 300 seconds, I believe, which is more than 120 seconds. That means after 120 seconds, it will again start generating the attack traffic. And then again, the port will be blocked. So that's it. And it will, and we, so after all the process, after running the controller and detecting and mitigating the DDoS attack, there will be 3 CSV files created. I have already shown you 2, which is switch data and flow count. And another main file is results.csv. So the switch data, which will have the parameter counts for SFE, SSIP, and RFE. And these will be parameter counts for these will be parameter counts, and one more is for the flow count. This is for flow count. These are the flow counts on the traffic on a specific time interval, like which is 3 seconds, as I have showed you earlier. So these files, these CSV files will be used to generate the graphs, and I'll show you how the graphs are turned out to be. So, and I also have Python scripts for generating detection rate and accuracy. So let's see those values as well. Uh, so let's go to analysis folder and run these scripts for finding out the detection and accuracy. As you see, I have already run this earlier, but let me run again. So here you can see accuracy is like 90% something. So the accuracy is much higher than the methods we have seen in other like other related works. Uh, in cross validation score is 0.909. That means it's like 90.9, which is still a good success rate, as I can say. Next, we will run the detection. So the detection rate proves, which means all you as you can see, the detection rate is 0.974 something. That means 97.4 something. Um, which means no normal traffic was detected as attack traffic and no normal traffic was blocked from the port. So only the attack traffic was blocked. If you see false alarm rate is like zero point 0.1, which is very minimal. We can ignore that. And this is false. Even this 0.1 comes because of the less data. Right now, I have run the scripts only for 300 seconds. But if we run the scripts for more than 600 seconds, the data will be more accurate than and then the SVM will predict the exact results. If SVM has more data, then it will give 100% accurate. So we can easily get detection rate as 100. So that means there is no false positives. Let me also generate the graph. So the graphs are generated. You can see these are the graphs. Let me go back to the slides to explain the graph values. So this was the graph generated from that set, from the set of the data which we got. Uh, SVM DDoS decision region boundary. On the x-axis, you see we have incoming packet frequency. On the y-axis, it's source IPs per packet. So it shows, it compares both of these values, both of the parameters for normal traffic and attack traffic. In the blue area, which you are seeing here is normal traffic. Uh, and the attack, the norm as the normal traffic predictions, and the rest of the area is attack, or all the orange area is attack traffic, which is from SVN prediction. As you can see, the attack traffic prediction is done right way and it goes up drastically. So this was the SVM prediction graph, and it is also working accurately. For DDoS attack, the traffic will be gone up like drastically. That's how it works, right? So we can say this is working as expected. So this is the demonstration of our project. The only limitation of this method is if the data set which was used to train the SVM algorithm if it has any faults in it, so the SVM would not work. And also if any trusted IPs which was used to train the support vector machine algorithm, uh, then there is a possibility that it will generate false results. Um, like for future work, we can plan on having multiple controllers and switches in the network technology. So far, as I showed you, like we were using only in our topology one switch and 10 hosts, but in future we can definitely increase the network with more switches and more hosts to get more accurate values. And currently we are extracting only three parameters from the network, but in future we can add more parameters to be defined. Again, we can deploy this method in real time, local traffic, to evaluate if you are interested. Thank you so much.